Hello everyone, my name is Makayla Hogg and I will be presenting my project for noise level analysis with Circuit Playground Express. I am in my last semester of college for my degree in software development. Now let's get started. Now my project objective was basically to be able to monitor and analyze the fluctuation in noise levels in my office space using the Adafruit Circuit Playground Express. Now, by recording this audio data, this project aimed to track environmental noise fluctuations and assess the correlation of office activities over time. Now, if you don't know what a Circuit Playground Express is, it's basically a microcontroller which is equipped with a built-in microphone. The device was then programmed to capture audio fluctuations in the office, and I was able to record the data and store it in CSV format to be able to see the different noise patterns which can be seen throughout the week. Now, as for tools and materials for this project, for hardware, I did use the Adafruit Circuit Playground Express. I used a micro USB cable to basically be able to power the device and transfer the data. And I also had, of course, my computer. Now for the software, I did use the Adafruit Circuit Python for MU. I used a Microsoft Notepad, which is just the built-in software in a computer. And then I also did use Microsoft Excel to be able to analyze and visualize the CSV data. Now, of course, as for the programming language, I did use Python. As for methodology, the first step that I did for beginning this project was the hardware setup. As for hardware setup, I did go ahead and move the Circuit Playground Express into a fixed position in my office location. My office is a circular office and my desk is one of the middle offices, so of course I thought it would be most useful to be able to mount it somewhere in my area so that I would be able to get a nice circulation of the noise levels. Now for the microphone of the device, it was set up to pick up sound and then of course convert it into a digital value to be able to represent the audio levels. The next step I did was actually programming the device. The device was programmed using Adafruit Circuit Python for MU, which is a Python-based language designed to run on Adafruit boards. The code was written to detect sound levels throughout the built-in microphone and then record those sound fluctuations as numerical data. Now, as for how often this was recording the audio, it was recording all the time, but as for actually taking down the data, it was set for 10-minute intervals between the hours of 7 a.m. to 5 p.m. or 1700 hours. And then it saved the data in the CSV format, which I could be able to export for further analysis into Excel. Now for the last step, that was data collection and export. The device was continuously reporting the data throughout the week, Monday through Friday, and on weekends as well, Saturday and Sunday. And then that data was stored into a CSV file and periodically exported for the analysis in an Excel spreadsheet. Now the implementation of this actual project first began with downloading and plugging in the actual device into my computer. So I was able to plug in the device and then install the firmware update for the device to be able to actually program it. The next thing I did was I did go ahead and mount the device. You can see in the picture on the right, this is where the device was located in my office to be able to record the sound levels evenly. Next thing that was done was the actual implementation. Now, for the implementation, I did go ahead and use MU for the IDE to be able to actually develop this code. In the actual code, you can see a couple different things going on, one of which is going to begin with activating the microphone, being able to actually be able to make that a usable feature on the CircuitPython Express. The next thing was being able to also use the colors of the LEDs on the device. So one thing that I did notice was if you didn't have any piece in your program to actually light up the LEDs, then they don't light up at all. None of them do. So it does get a little difficult to know if the device is actually recording or not. So one thing I did was actually change all those LEDs to green so I knew it was plugged in and actually recording the audio. Now the next thing I did was go ahead and set the date and time that the project was beginning, which was November 1st of 2024 at 7 a.m. Doing this did kind of assist me in actually getting a accurate read of the date and time, just because that was not the default time. The default time was sometime in 2000 on January 1st. So that was something that I did notice, not initially, that I needed to change in my actual program. The next was being able to read the actual audio levels and the fluctuation of the sound, and also in turn put that as a timestamp as well. So on the right hand side, you can see this is the way that the format was coming out after this code was developed. So the first thing you'll see is the date, which was 11/1. That was the day it started. And then of course you can see the 10-minute intervals, which I had set through the program to start at 7 a.m. and it basically went every 10 minutes from there. And then as for the sound level, you can see that the sound fluctuation starts typically around 22,000 when there is actually sound going on. Now, as for data analysis, the one thing that of course was recorded was weekdays and weekends, just so I can go ahead and see if the data showed a significant peak of fluctuation on some days versus others, or certain hours versus others. Of course, as for the weekends, basically just verifying that there was no fluctuation because no one works on the weekends, so there was an absence of activity in the office on those days. One key insight was that you can kind of tell the active periods throughout the day depending on meetings, phone calls, and general office noise, just resulting in higher sound levels. Now, this first chart here that I'm showing does show the noise level analysis from November 1st, 2024 to November 19th, 2024. Now, those significant drops you see are going to be weekends when there is absolutely no noise levels at all going throughout the office. Now, you might be wondering, how is there absolutely no noise? It is because in my office space, there are no windows, no outside activity that can be seen or heard. It is a completely soundproof office from the outside world. To get a closer view of the actual data being recorded, though, I also did put together a additional chart here, which again is the noise level analysis on the same days, just with the weekends actually excluded. Now in this data, you can see certain peaks of time on here, which we'll go over in just a second. But I just wanted to go ahead and make it clear that certain activity on this chart, it does fluctuate throughout the day, just because at my office we are taking a high volume of calls. So there really is not a point in the day besides when everyone is gone that there is absolutely no noise, just because it is pretty consistently noisy in the office space. Now, as for the results and findings, of course, it begins at the fluctuation in noise. For weekends, there was a clear fluctuation in sound levels with high peaks in the late afternoon and in the mornings. As for weekends, there was absolutely no activity. Sound levels at 0 basically represent that no one was in the office. Now, for some key patterns, one was the peak activity times, which were basically the highest around 8 a.m. to 9 a.m. My office is one that people kind of drift in to in the mornings. Everyone kind of starts at a different hour from 7 a.m. to 9 a.m. So, of course, there is higher fluctuations during that time, as well as the late afternoon when people are leaving for the day, which is typically around 4 p.m. and 5 p.m. Another key pattern is going to be quiet periods, which are typically detected around 7 a.m., which is the early morning time when not a lot of people are in the office, as well as midday around 10 a.m. to 3 p.m., which I believe is when people are typically taking their lunches. Now, a couple technical challenges that I encountered, one being a CSV export issue that I was struggling with. One of the primary challenges I first encountered while doing this project was being able to export the sound correctly into a CSV file. I did struggle configuring the system because the first IDE I was using was MakeCode, which is virtually impossible to be able to actually export data from. And I did notice that even without trying to export it, it was not recording the data as well. So I did struggle with that, but it was a challenge I was able to overcome. The next thing was the timestamp accuracy. One thing that I kept struggling with was when I was trying to initially start this project, I was trying to record minute by minute, which in turn was causing my actual program not to run on my device, and basically my device kept crashing. And would stop collecting data, and I believe it was because it was just too much data to actually be able to handle. One other thing was trying to use the real-time clock to capture the noise precision for this time, so I had to actually set that as well. Another technical challenge was, again, the switching of MakeCode to CircuitPython with MU. Initially, I did try starting this project using MakeCode because it's simple and block-based, and I just thought it would be something to be really simple to actually understand how this device works. However, I did run into those difficulties, being able to export data and being able to read data at all through the program, which in turn led me to switch to CircuitPython using MU just because it's more flexible and I was able to write the data directly. As for some successes and disappointments, some successes I had was the effective data collection of this. Although I did have a couple setbacks using the Circuit Playground Express, I was able to successfully record the ambient noise levels in my office over several days. This data, of course, provided a clear insight into noise fluctuation throughout the weekdays versus the weekends. And then another was being able to overcome that hurdle of not being able to accurately export the data that I was recording. So that was a huge success for me. Using CircuitPython with MU, I was able to capture and store the noise data in a structured format, and then basically allow me easy analysis using Excel. Another was the project adaptability, being able to switch from MakeCode to CircuitPython with MU turned out to be a huge, valuable decision. It allowed me to overcome that technical limitation in MakeCode, basically allowing me to have a smoother workflow and better control over the data and export process. So I was very happy to be able to achieve that goal. A couple disappointments that I had was the limited granularity due to the timestamps. Because I was not able to record minute by minute timestamps and I had to switch to 10-minute intervals. This did reduce the precision of the noise analysis that I was able to record. However, I do still believe I recorded accurate data. Another was the MakeCode limitation. While I had hoped to use it just because it was simple and easy to understand how it was actually working, I did run into that challenge, which did take me a little bit to overcome when trying to export the data to a CSV. And then another, of course, is going to be something that's not a huge deal, but because Circuit Playground Expresses has a built-in microphone, I believe it wasn't the most highly sensitive microphone that I could have used. So I do believe that a more sensitive microphone would have been able to record more detail into the sound analysis and just have better quality overall. Now, to conclude my presentation, just a quick summary of my findings was that my Circuit Playground Express was able to successfully record noise audios throughout the week, basically being able to capture the fluctuation during work hours and quiet times on weekends. It did also clearly highlight higher noise levels during work hours on weekends and zero levels on weekends. when the office was actually empty. And then, of course, by exporting the data into a CSV file, I was able to analyze and visualize these fluctuations over time. As for the impact, my project demonstrates the potential of using the CircuitPython with MU for environmental monitoring. Working in an office that received a high volume of calls, this information can be super useful because it provides an insight into noise patterns that could definitely help improve the office environment or even help with designing a noise reducing interventions throughout the office. As for future improvements, if I were to ever redo this project, one thing I would definitely want would be longer monitoring. Being able to collect the data over a longer period of time would definitely help with more detailed patterns. I know I did start the actual recording a little late, but that was due to some limitations that I was having in technical difficulties. However, I do believe if I had recorded the information over a longer duration of time, I definitely could have been able to see a little bit more patterns going on. Another thing that I would definitely do if I could redo the project would be integrating other environmental sensors to create more comprehensible monitoring system. Just because sound analysis is great, but environmental levels, maybe temperature, something like that, would also be an additional factor that could kind of lead to different noise levels as well. One last thing would be to set up automated alerts, just basically telling you when things exceed a certain threshold. That way you can see, I guess, a little bit more accurate timestamp and kind of have a sense of when or what was going on during those high fluctuations of volume. This does conclude my project. I would like to thank you for listening, and I hope you have a spectacular rest of your day. Thank you so much.